Everyone, my name is Vikas. Today is our topic on basic home automation introduction. Home automation refers to using technology to control household devices automatically or remotely. It integrates common home functions like light, fans, etc. with a single controllable systems. Basic home automation uses devices such as smart switches, controllers, sensors, and mobile apps. It uses monitor and manage homes functions from anywhere using smartphones or voice assistants. It increases energy efficiency by ensuring appliances operate only when needed. It serves as the foundation for more advanced smart homes technologies, enabling future upgrades and expansion. The other topics will be explained by the teammates.
Hello everyone, my name is Gururaj Naikal and I am here to explain the circuit diagram and the components and the connection of our project. Let's see the circuit diagram first. Here you can see the circuit diagram has shown like this, and the components are microcontroller which is we are considering the Arduino ESP32 to control the signals. It is provides the connection between the interface user and with the devices. The sensors, we are using the temperature sensor and the sensors which is connected the devices each other. The sensors are DHT11 temperature sensor, and the cable wires used to build the connection between the components. We using the multiple cables like jumped cables, male to male, female to female, or male to female cables. The breadboard is basically used to communicate with the devices from one device to another. It gave the platform to communicate the devices like hardware to software, software to hardware. This provides a very good opportunity to communicate the devices used to assemble the entire project circuit, including the ESP32 temperature sensor and the fan connections, light connections, etc. And let's moving on the connection part. So in this, we are taking a fan which consists of a positive and the negative nodes. Let's take a connection. Let's build a connection. We're taking a red wire to show the positive connection. After the connecting these wires with the fan, we are connecting with boards. We are putting our negative here, and let's put a positive node little bit far. Okay. Next, we are building a connection with the sensor, which is ESP32. Taking a female jump cable to connect with the positive, we have indicators concluding with the numbers. Taking the positive cable with the D15 or 19 depends upon the user. We're taking another cable. Now we are connecting this with the fan. Now let's connect with the humidity sensor. We are using this cable for the output. One point here and another point here. We're taking another cable to passes the input, which is also considered as a positive connection. And last final cable, which indicates the negative.
Hello everyone, my name is Ingraj. I am here to explain about the microcontroller we used in our IoT project. The name of the microcontroller is ESP32. The ESP32 is the central microcontroller used in this home automation project. It acts as the brain of the system, responsible for the reading sensor data, processing it, making decisions, and controlling the fan based on the temperature. Key functions of the ESP32 in this project. Reading the sensor data. The ESP32 receives the temperature readings from the sensor. Sensor I used is DHT11 through its GPIO pins. It converts this raw data into usable temperature values. Processing and decision making. After reading the temperature, the ESP32 compares it with the predefined threshold temperature. Example 30 degrees Celsius. If the measured temperature is greater than the threshold temperature, then it turn on the fan. If the measured temperature is less than or equal to the threshold temperature, it turn off the fan. Controlling output devices. ESP32 sends a control signals to the transistor or a relay module driver to switch the fan on or off. A driver circuit is used. Communication capability. Since the ESP32 has built-in Wi-Fi and a Bluetooth, it can also send a temperature data to a mobile app or a cloud dashboard. For IoT-based monitoring, this makes a future expansion of the project very way. Why ESP32 is used in this project? Built-in Wi-Fi, ideal for IoT and home automation. Low power consumption and fast dual core processor. Multiple GPIO pins for interfacing the sensors and actuators. Easy to program using a Arduino IDE. 3.3 volt logic, compatible with the most sensors. Second one, role of ESP32 in the system architecture. Acts as the controller and a decision maker. Interface with the temperature sensor. Sends a signal to the driver circuit. Controls the fan automatically. Can communicate with the user or apps if IoT features are added. uh, Last but not least, advantage of using ESP32. Compact and powerful. Supports IoT connectivity, reliable for continuous monitoring, cost effective for small automatic automation systems.
Hello everyone, my name is Nitin and I'll be explaining about the temperature sensor DHT11. In this project, a temperature sensor DHT11 is used as the main sensing component. Its primary role is to continuously measure the temperature of the surrounding environment and send this data to the ESP32 microcontroller. How the sensor works? The temperature sensor detects the heat level in the room. It converts this physical temperature into electrical signal. The sensor sends the measured temperature value to the ESP32 through the data pin. The ESP32 reads this value and decides whether to turn the fan on or off. Key points. Why this sensor is used? It is simple, low cost and accurate enough for home automation. It operates at 3.3 volt, which is compatible with ESP32. It provides real-time temperature updates, which is essential for automatic fan control. Role of the sensor in the system. Monitoring. Continuously checks the room temperature. Input to controller. Sends the digital analog value to the ESP32. Decision making. Helps ESP32 compare temperature with the threshold. Triggering action. When temperature exceeds the limit, the ESP32 activates the fan through the driver circuit. How the sensor influences automation. If the temperature increases, ESP32 receives the updated value. Fan turns on. If the temperature drops, ESP32 updates again. Fan turns off. Thus, the sensor is the core input device that makes automatic control possible. Advantages of using this sensor. Easy to interface with the microcontrollers. Low power consumption. Stable readings for home environment. Works well with the IoT platforms. Thank you.